Okay, everybody, welcome to the second session on the second track of the second day of Plone Conf 2020. Wow, lots of twos. And our next speaker is Calvin Hendryx-Parker, CTO of 6 Feet Up, talking to us about running Plone on AWS.
Awesome. Thank you very much. All right. I want to welcome everybody to Plone Conference 2020. I'm excited to be here speaking at a Plone conference again. I haven't been in a couple of years, so it's nice to be back. All right. Let's kick things off. There'll be, if you have questions, make sure you drop them in the Slido on the side, and I'll make sure that either I or Fulvio picks that up and we'll answer those. And then after the presentation, I will be live in the Jitsi room. So if you want to check out the face-to-face link down below, I will definitely be partaking in that and answering any questions. There's some cool stuff in here. The GitHub link there will take you to the slides for the presentation. In addition to, there's a demo folder in there, which will show off some pretty cool stuff that I'm kind of working on now for deploying Plone on AWS. All right, let's get started. My name is Calvin Hendryx-Parker, and I'm CTO and co-founder of 6 Feet Up. I've been a long-time member of the Plone community, and before that, the Zope community. But I've been a happy Pythonista since probably the year 2000. Puts me into the old people's realm of Zope and Plone usage, I guess. And then in addition to that, I am also an Amazon Web Services hero. So I guess they think I know a lot about Amazon Web Services, so that's kind of cool. So please ask questions away during the session. It's pretty free form as far as like what I'll talk about. That way, if you guys do have questions, happy to answer those things and kind of get things going. As we do kick things off, I want to let everyone know 6 Feet Up is hiring. So if you are interested in coming and joining an awesome team of people, we are very fun people to work with. Check out the website, 6feetup.com/company/careers, and you can come and hang out with us and do fun, cool stuff like building platforms for virtual events, which is tons of fun. Oh, cool. So, thanks for posting the link into the Slack channel for me. All right, kick things off. Why are we doing this? And I hope this stuff that I'm going over here at the very beginning is fairly, I guess, obvious to folks. But beautiful, unique snowflakes are not reproducible. And what I've found out so far is that in the enterprise, there's still a lot of beautiful, unique snowflakes that we need to contend with. And those are things that run once on one server in one set of conditions and never seem to be reproduced again. A little side bit of trivia: did you know that chances of a snowflake being exactly alike is 1 in 1 million trillion? That's a 1 with like 18 zeros behind it. And sometimes I feel like the software that I run on some of these servers, or I've seen running on some of these servers, only has about that much of an odds of running anywhere else other than the server it was originally deployed to. So if we talk about our servers and our services, actually we're going to start talking less and less and less about servers themselves, even virtual machines, and we're going to move more into kind of a serverless mindset, and we'll go there on this whole journey. But we talk about servers. I think back in the old days, people used to talk about their servers with cute names, kind of like pets. If they got sick, you would nurse your pet back to health. Same thing with your email server, because if that email server went down, there would be lots of problems and lots of people calling your phone, and you would not be happy, and your pager would be blowing up. So we kind of treated our servers and services like pets. Now, the analogy here, which is coined by Randy Bias after hearing his talk from Bill Baker at Scaling SQL Server, really led us to say we need to talk about our services and servers more like cattle. And I know that may offend some animal rights activists in the room, but I mean no offense. Other than we typically don't refer to cattle by cute names. We typically give them numbers. If one gets sick, we may pull it apart from the herd. If it can get better, we can put it back. But if not, we'll replace it with another one typically. So we're really living in this world of a DevOps where non-cloud native applications need to have the ability to be deployed onto cloud native tools. So how do we take, beautiful handcrafted, bare metal servers or applications that are running in on our servers in our closets and moving them into the cloud? How do we take this from the closet to the cloud approach to moving our systems and our servers? And since Plone existed prior to really there being any semblance of a public cloud or a notion of even private clouds, we always kind of got started with a history of, it's a big monolith. We run on one server. You typically have the application, your web server. Actually, it looks a lot like this. We're going to have a single server monolith where maybe we've got a cluster of Plone instances using Zio, and we're running a Varnish instance and HA proxy for load balancing, and we've got Nginx doing, our URL rewriting. What could possibly go wrong? Now, this picture does appear deceptively simple because what's missing here, what fails typically in these situations, is going to be things like dependencies and OS patches. How many times have we gotten bitten by a security vulnerability in OpenSSL? And upgrading that package means you now have to recompile your Python, which means they have to have their patches all in order and all your libraries have to line up. And if in the meantime you had upgraded a major or minor version of your operating system, you almost end up in a spot where rebuilding the server from scratch probably would have been quicker, faster, cleaner, and ended you in a spot where you were in less of a snowflake type situation. Because how many times have you gone onto a server, maybe back in the days? Maybe I'm speaking to kind of the older crowd in the room, where we would hop on a server kind of as pull up our boots by our bootstraps and run some commands and invoke the pseudo gods to fix a problem at the last minute, only to have it bite us, months down the line. I can't tell you how many times I've sat in front of a server, fixed something really quickly, thought to myself, there is no way I will forget what I just did here. Only to 6 months or a year later, jump on that server and be like, what in the world happened here? How did I end up in this state? So that's definitely a common problem. But what if we could move Plone into a more cloud optimized type of a deployment? I talked a bit about this not last year, this year's Plone Web Python Web Conference, but in the 2019 edition of the Python Web Conference, we talked about moving Plone into a cloud native type of a deployment. So taking what was the monolith from the previous slide here, taking those pieces and breaking them apart into individually deployable services and leveraging kind of cloud native building blocks whenever possible, instead of managing our own servers and services by hand, or even using some kind of orchestration scripts. So if we look at this diagram right here, what we're looking at is taking Plone and deploying just the Plone process onto some EC2 servers. That is, really what we're seeing here in this middle orange tier, is that we've got Plone and HA proxy because we still need rewriting because the application load balancer is in front, can't do it. But we're going to take the rest of the pieces and replace them with cloud native tools, cloud native versions of those tools. So, for example, instead of HA proxy, we're going to use the application load balancer, which is just a built-in managed load balancer that is part of your cloud provider. In this case, we're using Amazon Web Services. Instead of Varnish, we're going to use a CloudFront CDN, which actually can give us a couple benefits in that, Varnish, it works great on one server and can accelerate the cache for one piece of the equation. But if I actually want to be able to have a full CDN, which is a content distribution network that has points of presence around the globe, Amazon is well over 200 points of presence now. I'm not going to go deploy 200 Varnish servers on my own. So I can take advantage of that piece of this equation where I don't have to manage my own caching servers anymore. And also, as a side benefit, you can see the AWS WAF, so the Web Application Firewall. We can now layer right at the CloudFront layer, right at the edge, Web Application Firewall rules to help protect our site from denial of service attacks, or common, the WASP top 10, the OWASP top 10 vulnerabilities. There are basically pre-made, ready to roll profiles that you can throw onto the Amazon WAF for, I don't know, $1 or $2 a month to protect your site. I mean, at least to give a minimal version of protection there for that site. Now, on the backside, so that's all the delivery. We've replaced Varnish with CloudFront. We've replaced our HA proxy with application load balancer. We're still doing a rewriting here at this application server level. For blob storage, we can use EFS, which is the Amazon hosted version of NFS. So if we actually want to be able to scale our application servers horizontally, we can now do that by spinning up identical EC2 servers that really we don't store any data we care about on. There may be logs on there, which we could ship someplace else, but there's no data on these EC2 instances, which means one could get sick, one could drop off the face of the earth. I really don't care. I can just spin up another image of the exact same distribution or release, and I'm back in business again. All it does is mount up the blob storage, and then we replace the file storage part or the ZIO part of our application with rel storage, so we can use a relational database as our backend for ZODB, which gives us the ability then to leverage multi-AZ or availability zone clusters of databases on the backside. So now we're not managing database servers. We just have our interface to the database where we store our data being a just a connection string that we pass into our EC2 instance as we spin it up, and our blob storage. And we can even eliminate blob storage from this. The latest versions of rel storage really support storing our blobs inside the database, so that can even eliminate yet another component from this diagram. Now, there's still some complexity here that we're not talking about. And how do we end up in a cloud native uh, design like this? But what kind of there has to be kind of a bit more complexity going on here, because really they're going to be things like backups. Being able to back up our blob storage into S3 buckets, which you see right here. There's also going to be things we need like a control VPC. So where can we run all of our automations from? In our case, we're using Terraform and SaltStack to build our EC2 instances or servers that are going to be running the Plone application itself. And we need a kind of a command and control plane for that. And we don't want to be able to also spin up, say, a testing instance, a staging instance, a performance monitoring, trial and performance testing instance. So we're really going to start having multiple VPCs, which are those virtual private clouds. So our diagram actually starts getting a little more complex. Now I know this seems a lot more complex than it was when we were just dealing with the monolith, because it was just one server, one network, and not a lot of these other issues. We have gained resilience and performance here because we are running across two availability zones. So if you are running in Amazon, a region, so in this case, like US West 1 is going to refer to a specific region around the world. Each availability zone is a separate data center inside that region, separated by some minimum minimum distance, so that if there was a physical event that happened in that area, that it would not affect both, hopefully not affect both availability zones. So your best play here is to really try and spread your application across multiple availability zones. In case one goes away, you're still hosting your application across the other one just fine. So we've gained resiliency, we've gained the ability to scale horizontally. We can easily handle more traffic by adding in additional Plone application servers along the side here. I still don't know if we're really much better off though, because we still are managing virtual machines and EC2 instances here. So we still do have to worry about patching, but we can command and control and orchestrate all of that from a Salt Master. So from Salt Master, we can now do all of our orchestrations in a central location. Hopefully we're not logging into these EC2 instances like we were before with our monolith. So this should actually help simplify the administration of all of our services along the way. So again, I'm not sure if we're really better off, but where do we where do we start here? Let me go back to the slides. We kind of have a chicken and egg problem. If I wanted to launch my stack of software into the Amazon infrastructure, how do I do that before I even have that Salt Master out there? So we do have to build some more code or some more pieces here, either like Terraform or some kind of Bot03 scripts to actually bootstrap that control VPC with our Salt Master in it. And then from there, we can start building our other infrastructures. We did do this with a couple projects, which does lead to the ability to orchestrate and build other environments quickly. So for example, that environment I just showed could be production. You can deploy across production with just passing a different argument to our orchestrate runner. And if people have questions about Salt, I'm happy to answer those kind of maybe either in the face-to-face or in the Q&A part of this. but I really feel like we're moving along from here, and I'm going to kind of describe why we're continuing to iterate on this idea of a cloud native deployment for Plone, and why this I still think is not quite where we want to be. So I know it all sounds easy. Well, maybe it wasn't because there's a lot of moving parts now. But there, we were trying to satisfy some specific rules. Like we wanted to make sure there were no special cases, so that we could easily redeploy those EC2 instances quickly with Plone, and not have to worry about special software configurations or different rules or whatever those case may be. But it was hard. Let's just say. Um, so if we kind of refer to my one of my favorites, I always tell my whenever I teach a Python class, I tell the students to always print out the Python. And if you're not familiar with Python, which I can't imagine you wouldn't be, but if you aren't, make sure you just go to your Python in terminal and type Python and then type import this, and you'll get a whole Python. But there's some interesting tidbits in there, especially there should be one and preferably one obvious way to do something. Although that way may not be obvious at first unless you're Dutch, referring to obviously the creator of Python. So we tried doing this cloud native deployment using different distributions for the EC2 instances that would be running the Plone servers. At first, I thought it makes sense to use the Amazon Linux version of EC2s. Since we're on Amazon, it seems like it would be highly optimized for that. But there are issues there. You can see here kind of the revisions. At some point, the Plone has certain dependencies that are needed for like, document indexing and rich text conversion and things like that. So Amazon Linux didn't work for that. I was like, well, okay, let's go to CentOS. That seems like a nice stable place to be. That might be fairly modern. Again, they were behind a version on HA proxy, I believe, which we needed a specific feature for doing the rewrite rules in HA proxy. And then we refactored back to FreeBSD, which was kind of my operating system I've grown up on. I was trying to go more the Linux, easy path this way. But in the end, refactoring back to FreeBSD for our VMs worked well because FreeBSD has a fairly modern packaging system on there called package-ng, which gives us the ability to get latest versions of those packages. And all of our dependencies worked just out of the box, kind of a Mac OS kind of experience when it came to building our virtual machines to host on Amazon AWS. But again, it was a lot of work. Between that and the shifting environment of ever changing Amazon Web Services APIs underneath the covers for doing the orchestrations, we're constantly making sure we're on the latest versions of Salt, constantly making sure our versions of Terraform are up to date, making sure we always adjust and test our Bootstrap scripts, because you think you would get something scripted, ready to redeploy at a moment's notice, only to find out that it had bit rot over the past couple months because nothing in the cloud really ever stays static, and it is really a very dynamic environment, so it's difficult to keep up. So I think if you think you're safe by just scripting something out, it kind of, I don't know, almost old school. Be careful and make sure you have at least some kind of continuous integration running that is testing that it actually works the way you think it does, because it's probably going to break over time as things in the environments change. So where do I see the way forward here? What is our road forward with this whole process? Because I'm still not super happy with running full blown operating systems, and I really want to get into kind of a more serverless way of maintaining these things, or even using containers. Well, let's look at the road forward and talk about what we're seeing today. You can see I've refactored my system architecture diagram. And instead of using Amazon EC2 to host our Plone application, I've switched this up to use this is a Fargate right here. So Fargate is Amazon's serverless container hosting environment. If you're familiar with Amazon, they have a plethora of three-letter acronyms. This one is called ECS, the Amazon the Elastic Container Service. And originally, Elastic Container Service was an easy way for you to manage running containers on your existing EC2 instances, but you're still responsible for running, upgrading, patching those EC2 instances that are running your base operating system. Kind of the other side of this extreme is going to be things like Kubernetes or hosted Kubernetes, like the EKS product. Kind of nestled in between those two extremes is Fargate. And so Fargate is a fully managed orchestration environment but I'm not responsible for all the complexities that I'm just perceiving with Kubernetes. I'm also not responsible for managing and patching and maintaining EC2 instances to run my own containers on these systems. Because if you started messing with containers and started messing with a lot of the serverless technology, sure, the container experience is great and the developer experience is even better because I can quickly spin up new developers and onboard them quickly. But the deployment experience really needs to be, well documented, well thought about to make sure you don't trip over yourself as you go. And so that's why I've chosen for this specific example to talk about using Fargate for deployment. So we still have the same cloud front up front, still have our web application firewall. We're still using Amazon load balancers, the ALBs, so we can actually scale across this private subnet. And now, if you're using Fargate and you deploy Fargate containers, they're called tasks at that point, it will automatically start putting your tasks in your region across the multiple availability zones. So again, one less piece I have to kind of think about or worry about or even orchestrate or have defined as part of my software defined infrastructure. That part all just kind of happens for me in the background. And then the same thing goes for using the RDS, the Relational Database Service multi-AZ. So that at least guarantees that I'll have a read-only copy of my data sitting in some availability zone other than the one I'm primarily hosting out of right now. And if things do fail, the the managed Postgres RDS service, relational database service, takes care of switching where that connection string is pointing to, whether it's in the current master AZ or if it's going to go to the backup availability zone in the case of a failure or in the case of upgrades. I mean, another big benefit to moving to a cloud forward, cloud native style deployment strategy is going to be the ease of being able to upgrade things like the database servers and doing maintenance on those pieces. I think there's a lot of database servers that are probably in production today that people are afraid to touch because if they upgrade it, they're afraid it may not come back to life again. So there's if if you make it easy to keep the services and software up to date, I think that it will be more likely that it'll happen, which means you'll be less vulnerable to security issues. You'll gain the benefit of all the performance that comes along with new versions and new features that come out with these various pieces of software. So we can now use rel storage on Plone containers. These containers are very, very lightweight, very, very easy to deal with and deploy compared to a lot of the technologies. Let me kind of now move into more of a quick demo here and show what I'm talking about. So let's move over to Firefox. Okay. So I've put together, I guess it's kind of a proof of concept at the moment. I'm calling it Diet Plone Docker, mostly because I was dissatisfied with the state of the Docker usage in the Plone community. Because at least this is from about a year ago, and I've not checked out recently what it looks like, but I know that the current, well, at least at that point in time, the Docker container, maybe official Docker container for Plone, was still using build out under the covers to build a Plone instance and pull down all the eggs and do all the kind of things you would normally do inside of a regular full blown virtual machine inside of a container. But I think the the point of using containers is that it's already a packaging technology. I don't need to package inside of my packaging technology another packaging technology. I think it just adds the additional bloat, which meant that the Docker images for those um, Plone distributions were going to be kind of large, a few hundred megabytes, I think even 500 or 600 megabytes large. And when talking about cloud native, I want to be kind of light, agile. I also want to have a very thin base layer that I can now build my projects on top of. So that's why I started this other project called Diet Plone Docker. There is a GitHub repository for it out there. It does get pointed to from the demo. So if you're on the GitHub repository for this talk, there is a demo directory in there that has the Docker file that I'm using for this specific project. But if we look at the Docker file, let's see here. We look at the Docker file for the specific one. If we look at this build, this was only possible because of the latest versions of Plone running on Python 3 and using Waitress as a server instead of Z server. So we ditched Python 2. This is definitely not Python 2 applicable at all. But what I want to focus or kind of highlight here is part of this process is a multi-stage build. To actually get a Plone installed onto your local computer requires a lot of development libraries, for things like, compiling Pillow and other pieces that are needed. You really need to be able to build a multi-stage build. And so kind of a little bit of Docker background. Each time there is a from line in your Dockerfile, that is going to start a build. And each time there is a run or a copy, that is a layer inside of that part of the build. So in our case, I'm going to build an image called build, where I put all my development libraries, all the GCC stuff, all the things I need to compile and get going. And we're going to put all that into this specific image. And we're going to create a virtual environment in there, build and compile everything. We'll install all. This is super nice. To all those who worked hard on this, I know Moritz and team and a few others who are all kind of working on getting the ability for us to pip install Plone. This has been super helpful. Recently, in the latest 5.2 releases, there is now a requirements file and there is a constraints file, which are really the key bits that were needed to make this all happen and actually work well. So if we do all these bits in our build, and then I copy in my requirements. So if I have custom requirements for deployment, I throw those in there as well. And then we have an image now that we're going to take and hold on the side. We're going to make a new image, which is going to be our one we actually deploy. So our key here is to produce as few a number of layers inside this Docker image as possible and as little data inside that Docker image as possible. So this is a very slimmed down, it only has the bare minimum things. We basically make sure the directories are there so it doesn't complain when it starts up. We install the bare minimum things we need to actually run Plone and not their development libraries. And we also, app clean and purge and make sure there's no other extra bits laying around so we can kind of get this thing slimmed down as small as possible. And then this is where the real magic happens is we copy from the build image into this deployment image. So we're going to take from build and copy our Plone root into this deploy image. And same thing about copying our settings. And then the last bit down here is going to be, well, we generated a init user password, random password, because I didn't want to hard code one in there. So every time you build a new Docker image with this Docker file, you'll get a new password for your initial user, which you should change, by the way. And then we specify what command we're going to run. So because we're running Waitress and using a WSGI server, it's nice and easy to use an INI file, which allows us a lot more flexibility than we did with the Z server stuff. So if you check that all out and actually build this, you'll end up with a container that will run and have just a plain Jane vanilla Plone running inside of it, which is a good starting point for us. The next bit is going to be taking that and running our code on it, like actually having customizations, running our own add-ons, and that's what the demo is in here. So if you look at the Docker file in here, it's going to be very small. We basically grab the latest, which is 5.2.3 right now. We have our own requirements file, and we install our requirements file, and that is it. It uses the same, init and command to run the Waitress server, and so we don't have to do anything other than just get our customizations installed into this specific instance. And so if we look at the requirements file here, for this demo, I'm just going to install collective.easyform into our instance just to show that it is possible to do this. So we go back up, and for running locally. So actually, if you all want to try this, this is where the kind of audience participation part comes into play here. You can literally clone this repository, go into the demo directory, and run Docker Compose up, which I will show you right now. We'll do that live. Let's go in there right now. Once I run Docker Compose up, if I didn't already have the image built, it would build the image, create the containers, and then start up my instance. And so you can see right here, we have started up the instance, and it's running on port 8080 locally. So if I go back to my browser and load up localhost 8080, we will see that there is a Plone site running. And so this is running in the container on my system, and we can log in. By the way, kind of a quick pro tip. If you want to see your init user, and there's a key distinction for folks who are new to Docker. We use the Dockerfile to build an image, but when we actually deploy our application, we're taking that image and producing a container that is based off that image. So if I actually looked in this container right now, let's go in here. I can do, I wrote, if you look in the make file, there's some conveniences in there. Oops. Oh, did I not put it in this one? That could be. Let me double check. What's in my make file? Oh, I don't even have a make file in here. Sorry. If I shell into this specific Plone instance or Plone container, which I could do Docker compose exec ti Plone bash. I'll just do sh. I think that should work. Nope. All right. I can't remember how to do it off the top of my head, but it's okay. The container will have consumed that init user file just like a normal Plone. When a Plone starts up or Zopes instance starts up, that init user file goes away as it reads it in and creates that initial user in your user folder. But the image still has it. So if I do docker run, and we'll just make sure that it's an ephemeral container. The --rm is important here because otherwise you're going to litter your system with a bunch of containers that are already set up or will be like created through this process. I'll do docker run 6 feet up / diet docker Plone, and then I can cat the opt Plone init user. Oh, did I miss? Oh, that's interesting. Oh, I guess I renamed it for this project. Hold on. Sorry about that. Let's use the image that I built for this specific project, which will be Cloud Plone CMS dev. There we go. So that's the username and password for this specific image. So let me grab that and we can log in. And there we go. We've got access to our ZMI, and it's all running inside the container. There we go. All right. Now, that's all fine and well. We've actually shown, running a specific version of Plone here. Let's actually add into this another add-on. For example, let's add in Mosaic. So inside here, we'll just add in Plone app Mosaic. Like so. Hopefully I typed that right. Okay. So we added in to our configuration file, which means if you add anything to your requirements file, you have to rebuild the image. So let's just do docker compose build. That will actually pick up, if there's any changes to diet Plone Docker, it'll grab that. It copies our requirements file back in to the fresh build image, and there it's grabbing EasyForm and Mosaic. So you can see there it's actually downloading and installing the tiles and Mosaic requirements. And this last bit is kind of the tricky piece. Anytime you start and stop a Docker Compose instance, like I've got one running up here on the top pane, the container is still sitting there because I didn't run it with like docker run --rm. So in our case, if I just restart this, it's not going to use the image I just built down here in the bottom. So you can see it's actually finishing up right now. So if I stop this one, we will do docker compose rm so we can actually remove the containers so we can build new ones or put new ones in place from what we just built. So now if I do docker compose up, it will create new containers. You can see it created a new demo Plone, and now it's attaching to them. And once that starts up, we should see in our Plone management interface the ability to install Mosaic. There we go. Oh, speaking of, Another thing to note when you're using these demo files here is when you do delete that container, that is the only place where your ZODB was stored. There's not any volumes used here yet. If you wanted to actually enhance this one step further, you could add a volume to store your blob storage and your ZODB. But I didn't. So anytime you do that, you're going to get a prompt to create a new Plone site. But just as easy as clicking create new Plone site for playing with this makes it nice and easy. Once we get the new Plone site created, which you can see happening here in the background, and we go over to admin and site setup and click on our add-ons, you will see we have Mosaic available. So that worked. We were actually able to install a product into our fully containerized, build out free. There were no build outs that were harmed in the creation of this specific instance, uh, Plone instance. That's awesome. So I've got it running locally. It's actually running an Nginx container on the front. You saw there was a web portion to that as well. If we go back to our compose file over here, we just started up an Nginx service using Docker Compose. We start up a web server and we start up a Plone server. And mostly we do that so that we can handle virtual hosting. So if we want to do the rewriting, we can actually pass into this like template some configurations for minimal configurations for our Nginx service, so we can support hosting this on a custom domain name like that. Pretty cool and pretty easy. Nice for developing locally. You can onboard a developer. You just give them this, the repository that gives them the Docker Compose. They Docker Compose up, and away they go. Now, how do I deploy this? If I want to put this onto the Amazon cloud, which is the reason all of you are here to see this talk, is I want to be able to, one command, throw this up into the Amazon Web Services cloud. And I did do that earlier because unfortunately, put, building and putting this in the cloud takes a few minutes, about 10 minutes or so, but it does work with one command. So I'm going to kind of slide up here to the top. The first thing you need to do, and I'm just going to demo a quick little tool here called Copilot. I have my AWS credentials in my environment. I installed the Amazon Copilot app, which allows me to quickly deploy a container from my local machine an image from my local machine into Amazon's ECR, and from there it will deploy a container into Fargate for me with some kind of nice presets. So with one command, so I'm running Copilot init. So I'm creating one called Cloud Plone with the name CMS. So that matches the name of my image that gets put up into the ECR, which ECR is the Elastic Container Registry, which the container registry holds images. I know that's confusing. It's just the words everyone seems to use for those things. But in this case, we're going to tell it to build from our Dockerfile, deploy an app called Cloud Plone /CMS, and it's going to be of type load balance web service. So it's going to go ahead and set up an ALB load balancer for us. If I go back and show you the picture, it is going to put all this in place for us, except for the CloudFront bit. We're just going to go from the ALB to Plone containers because I really wanted one command to show everyone how to get this up into the cloud. So it creates a manifest for you automatically. It uses the data inside the Docker file to figure out that it's going to expose your container on port 8080. It will create the ECR repository for you. And then it starts creating all the other infrastructure that's needed. And this is where it gets tricky because unless you're a Terraform expert or CloudFormation expert, there's a lot of ins and outs to building all these pieces. For example, internet gateways and public subnets and private subnets and routing tables and all the ECS clusters and all these other kinds of like moving pieces all gets kind of hidden under the covers for you, at least with this demo. Once you go to deploy this in a real, we'll talk about kind of the way forward from here. But what this has done is this goes through, it does build. So you can see it building our container, and then it pushes it into the repository. You can see this repository URL right here. If I go over to my AWS account and we look at the repository and I refresh this repository, we'll see there is the build from earlier today. Notice the size. It is only 174 megabytes in size, which means I can quickly deploy these things to Fargate. So from the Amazon ECR repositories, these will deploy to Fargate, and then basically container instances will be hosting our Plone and delivering the content for our site. On the ECS side of things, what it does for us is also produces a cluster for our containers to run in. And if I refresh this, you'll see that there's one service and one task running in Fargate. So in Fargate words, a task is basically your container running and serving requests. There are short-term tasks, scheduled tasks, long-term running services, and the Copilot tool actually can differentiates those for you. So if I do Copilot env status, oops, let's do list. So I have one environment called test. If I have an app, do app show, you'll see that I've got my applications called Cloud Plone. It's been deployed into a test environment with the one service, which is a load balanced web service. And there is the ability to do pipelines, so you can have a code build pipeline to deploy all these things. But the output of that was going to be is this right here, which is kind of important, the URL where it got deployed to. So if you actually go and follow the README in this repository, you will end up with a link that you can go to. And there's my Plone site up and running in Amazon Fargate with one command. So same username and password as we got over here. Let me go find it real quick. It's far back. There we go. And now we have a Plone site being created in Fargate, all deployed into the cloud, all ready to roll. And that was the one-liner, which is really pretty cool. If I go back to the slides, there's kind of a way forward here as we got a couple minutes left. The way forward from this, we did demo, is the developer experience. Now developers can use Docker Compose locally. They can commit into their own Git repositories. You can have pipelines that can build those containers, which push them into ECR, which is that container registry. The key there now is we can now build and deploy our tasks into Fargate. We can build up infrastructure using the console and the CLI to build infrastructure as code. We use Terraform and put that into our Bitbucket as well, which means that these same code pipelines and code builds will also generate and tear down and build and change and mutate our infrastructure all in a nice controlled way. So everything is stored in obviously source control management. So what's missing? The last bits of this are going to be being able to do things like passing in environment variables. Typically, the pattern you want for passing in things like secrets to containers inside of Fargate would be passing environment variables into the container for things like connection strings. The containers are already logging to standard out, which is nice because it means you can go over to CloudWatch and see the logs from your Plone instance all collected in one spot. That does work today out of the box. Next thing I'm working on is like the local dev of themes and apps, and then being able to build and deploy custom bits. So if you want to have like custom source or custom applications you're working on for your Plone application, kind of that pattern for working on those things. I believe that shouldn't be hard to do because we can use Docker Compose, bind and mount a local directory from our local file system into our containers so that as we are working on our code locally, the changes are picked up automatically inside of your Plone instance. And then deploying, which is really super nice. If I'm actually logged in right here to my Copilot, if I just do Copilot as a developer, deploy, it's actually going to find my app, find my stuff, see if there's any changes in it, build it, push it, and this pushes the latest version up into ECR one command. I have just deployed my changes from here. You can see it's actually getting Mosaic this time and pushing those Mosaic change into ECR for production deployment. So if I let that finish the end, I'll show kind of as my final grand finale, show that deploy showing up inside of ECR. We should just take one moment. A side note, if you do this demo, make sure you run the Copilot app delete command. It'll delete all the resources and make sure Amazon stops charging you for any of these things that you put up into the cloud. So here we go. It just finished the last bit. There, now it is pushing into the repository. And since most of the stuff already existed in the ECR, you'll see it only pushed two bits of the layer. So it's super, super fast to be able to do that. And it's actually deploying into the Fargate instances right now. But for kind of this demo, I'll just show over here. we should see a new version. There we go. There's our latest version of the code with Mosaic now deployed from this morning during the demo. And that is it. There's some questions. I will, if you guys want to jump into the face-to-face, I'm kind of running out of time here. I don't want to like go too much over time. And we can talk about that, but I can answer those questions in there. And I think I did answer how big is the image. Copilot is an Amazon Web Services tool for deploying these things, which is pretty cool. And it does run on top of the Amazon CLI. I don't know if there's any other questions I needed to hit. Did I catch everything? All right. Well, thank you all for attending. I will be going into the face-to-face momentarily here, and I can answer any other questions there. Thanks a lot.
All right, thanks, thanks, Calvin. The word that comes to mind for this is refreshing. Somehow, that's what it came to me. I guess we all like single commands, one-line commands to build the world, and especially for onboarding new people, I think that's particularly precious. All right, please jump onto the Jitsi if you would like to chat about this talk with Calvin and others. And otherwise, I'll see you in 10 minutes for the next talk on this track. Thanks.